let's say that you are a cashier, or we can say I'm a cashier, at one of those warehouse stores. I don't want to mention brand names, but a big store where people come in with big cartfuls of small items, groceries or whatever, and the orders are, we're going to assume that every order is over $100. Assume every order greater than 100. Okay? So, when you get a certain order, let's say you get an order that's exactly $200 and 0 cents. Okay? So then you're wondering, oh, this is the first time that I've ever gotten exactly 200 or exactly 100. You know, it's always, you know, maybe I've rounded it to the nearest 10 or something. I've gotten $110 even, but this is the first time that I've had 4 zeros in a row. That's kind of impressive. I wonder if this means anything about how many orders I've done or how long I've been working here. And so you think, okay, if I take every order, if say I get 197 and 64 cents, then I can take these last 4 digits for any order and just kind of turn that into, or think of it as, a 4-digit number, or a set of 4 numbers. 1, 2, 3, 4. So what's the probability of getting one specific set of 4 individual numbers? Because that's what 0000 is. It could be any special digit, in any particular set that you apply meaning to would have the same amount. If you say 1492, because I'm a fan of Columbus, if you say that's your particular set, then that would work just as well. But for this example, we're sticking with 0000 because that's what you got on this one fateful day at work. So how many numbers are there? Well, we have the probability of getting 0000 is, well, we have one particular set, so one favorable outcome, or one correct outcome, I guess. And how many outcomes are possible? There's 10 digits, 0 through 9, for each of these. Okay, so 0 through 9 times itself, times itself, times itself. So 0 through 9 to the 4th power is 10 to the 4th power, or 10,000. 10,000. So all this says is there's one possibility that we're looking for. That's the denominator, or that's the top half, and the total number of possibilities that you can get, if we count up 1111, 1112, if we were to count up all of the possibilities, it would be 10,000. So this is the probability of getting it on one particular try. Now, I have to draw a little diagram here. If we're talking about it being the first time, this is important, the first time that you've ever gotten this. Okay? Then what does that mean? That means that we can draw a little branching tree thing. This is your first order, and then you have the possibility of getting 0000, and that is a 1 in 10,000 chance. Or the other thing that could happen is you could branch in this direction and get something else. Anything else. And the probability of getting that is the remainder, 1 minus this, or every possibility except 0000, which is 9,999 over 10,000. Okay? So this is just your first try. I can label that first attempt. And then if you get it on your first try, you'll stop. But if you don't get it on the first try, you may keep going. And then on this try, you have the same probability, it's just extended. On this second try, or this second order, you have a 1 over 10,000 probability of getting 0000. I should put parentheses. and you have the exact same 9,999 out of 10,000 chance of failing. And this would just repeat. This would be exactly the same thing every time. So your probability, we have the probability of getting it on one particular chance. That's what this means. But if we want the probability of getting it for the first time, then we have to do a little bit more complicated set here. I'll get a new color. The probability of getting it on the first try, say you wanted to find the probability of getting it on your of getting it for the first time on your second try, it would be this probability multiplied by this probability, because it's the probability of this happening, this movement, and then also independently this movement has to happen in order to get us here, in order to get us to getting it for the first time on the second try. If we just had the probability of getting it on the second try regardless of what happened in the first time, then we would be all the way up here, and that would be different. So I'm just going to erase that to avoid clutter. I already have quite a bit of clutter. But I want you to see that we have to move down. We have to not get it on the first try, and then we have to get this particular thing. We have to get 0, 0, 0, 0 on the second try. If we wanted the probability of the third try, we would have to multiply this probability, 9,999 over 10,000, by 9,999 over 10,000, and again by 1 over 10,000. So the product of all these things would be getting it for the first time on the third try. I hope I'm explaining this well, because that's the intuitive part. This is the drawing diagram part, and now I'm going to get into more of the math. So I encourage you to watch me again. Watch that first part again. If you didn't understand that, I tried to be very explaining of it. So moving on, the way that we would express this in terms of just one simple equation that would take care of all of this, moving down, moving up, how many times do you go down, how many times do you multiply this, and how many times do you multiply the upward movement, is, you see, for every time that we go down, we have to multiply it by itself. It's just this, and then times itself, and then times itself again here. So we know how to multiply something by itself. We just write it to a power. Okay. So there is that. I'll put it in parentheses. And then we're going to raise it to the power of how many tries it took, which we don't really have a variable for yet. But what's that going to be equal to? It's going to be, I'll scroll down a little more. Well, the thing that we're looking for, I'll draw a big X, and we will say when, I'm going to write all of the parameters down here, when X is the probability of getting 0, 0, 0, 0 for the first time on that try. Okay? And then, oh, I'm out of space. I will define another variable here, and I will say I, because that's what I used. As a computer person, I think of this as iteration. This is not equal to square root of -1, if that's what you're thinking. I is equal to the number of failures. I'll write that. Number of failures. Okay? And then I'm going to put I up here. And I hope this makes sense, because we're taking this quantity, or this probability, and we're multiplying it by itself for every downward movement. And the only time we move downward is when we fail to get 0, 0, 0, 0. Everything that isn't, or the number of tries that didn't result in this thing is what I is. So that's how many times you try before you get it. Okay? So far in our equation here, we've said that the probability of getting it on a specific try is the probability of not getting it times the number of times that you didn't get it. But we need one more thing. We've accounted for every possible downward step all the way to infinity because we have a variable here. But we need this final upward step. We still need to take this into account. And the way to do that is we'll multiply it by, I just want to write an A. Well, I'll use another color. I'll multiply that by A times A. When A equals, and I think you can guess what A might equal, A is equal to the probability of 0, 0, 0, 0. Okay? And so if I'll simplify a little bit, 9999 over 10,000 is equal to the probability of not getting 0, 0, 0, 0. That's the symbol for not. Then we can just say the entire probability of getting the specific outcome on this specific try is equal to the probability of not getting it times the number of times itself, the number of times that you didn't get it, times the probability of getting it. So I think you can see graphically, every time that we go down, it's a blue arrow for this thing, and the time that we go up, it's a green arrow for A. And the number of times you go down is I. And then if you know the probability of getting it, I just wrote A, but I could have written, let me erase that actually. I don't want to make variables when we actually know what they are. It's 1 over 10,000. But we could also write this as variables. I could define this as n or something, and then we could plug in an n or n and a for whatever we wanted. If instead of numbers at the end of cashier things, we were talking about coin flips or die rolls, then it would be, 1/6 and 5/6 or something like that. But for this particular case, this is what we need. I can draw a better box than that. That's the equation to figure it out. And it doesn't give you a specific answer. I want to be clear about this. It doesn't tell you, oh, the first time you get this, you've definitely done 3,000 orders, because that's not possible. But what it can tell you is that let's see. This is, I should be more clear about what X is. It's the probability of getting it on that try. It's not saying you have done it I plus 1 times. If I is the number of times you failed, that doesn't mean that you've for sure done it that many times. It means you've done it, you have this probability of having done it that many times. So if this comes out to be 0.5, that means that you have 50% chance that you've done, let's say you put in 25,000 for I. So this times itself 25,000 times 1 over 10,000. And you get 0.5. I don't know what the actual math is, but that doesn't mean that you've done 25,001 orders. That means you have half a chance of having done that many orders. And if you get 0.9, if you put in a really big number for I, you might get 0.9 over here. And that means you have a 90% chance of having done, 700 million orders or something. You can never be absolutely sure. This will approach 1. This number will approach absolute probability, guaranteeing that you've done it that many times, but it'll never reach 1 because you can never be sure. It's all up in the air to some extent. And that's the best you can get, but it might be kind of useful and interesting to say, oh, the first time I got this, I wonder how long I've been here. There's a 50% chance that if I do 100 orders every day that I've been here so many days. Or if you're checking out at a place and the cashier says to you that'll be $100. Oh, that's the first time I've got an even 100. You can know, you can have some small reassurance that he's been there a long time if that's something that's important to you. It's just a neat little math thing that I sort of stumbled upon, and I hope you enjoyed the lesson.